I'll start by asking Bill, how many ICCFs have you done in your life, and what benefit did you gain from them?
This is my first ICCF, but I've been involved in another 10 workshops, mainly in Italy, but also in France. So one might say it's been 22 years since my first conference, and this is the 22nd ICCF. It's just a coincidence.
And have you gained benefits?
Well,
How would you define it?
I've gained sacrifices.
Yes. Okay.
No, it's been a pleasure to serve this community, and we've come almost like a happy family, I would say, of scientists who meet almost every year, and we have new results, and we enjoy discussing them, and so it's a mixture of technical and scientific results combined with some social activities.
Let's talk about this beautiful location we're in, which is Santa Maria degli Angeli in Assisi. Bill, first of all, can you tell us how you chose this and what was your impressions?
Well, actually, it was Claudio Pacci who suggested this place, and I came here last year to check it out, and I discovered that it's actually very famous all over the world, but it's not known to be famous because Santa Maria degli Angeli gave their name to Los Angeles in California. They were Spanish missionaries who went out, and of course they founded San Francisco as well. So it all started here. I like Umbria particularly because the food and wine are very good, the climate is perfect, the people are friendly. The hotel staff are very helpful. This hotel is the right size for our kind of conference. They have all the facilities in one building, so as we're getting all a bit older and not walking quite so fast, we can find our way around. In fact, this lecture theatre is on the ground floor, which is quite helpful for people, I think. This place happened to have all the right characteristics I was looking for.
All right, well, let's go on to talking about the subject we're here for, cold fusion, LENR, CMNS. 30 years of it. You've all been here pretty much through the duration. So we say the fire is still lit. So from a strictly scientific point of view, what has changed in 30 years regarding our knowledge of the phenomenon? Could you each address that? We'll start with Bill.
That's a very difficult question, I think. Sometimes I'm a little bit embarrassed about the slow rate of progress. Back in 1989, Martin Fleischmann and Stanley Pons claimed excess heat, and they thought they had some nuclear signals which actually did not turn out to be quite correct. And that really started a kind of race to find more excess heat to show that there was an abnormal phenomenon which needed some kind of explanation. A couple of years later, helium was shown to be a product of this abnormal heat reaction. But since then, there hasn't been a lot of progress, I have to say. So I'm a little bit disappointed that we still don't know definitely any one particular nuclear reaction which is occurring, and that's a disappointment to me. We haven't even shown that deuterium is consumed as a fuel. But we do know some products, and helium is certainly one of them. So it looks as if deuterium is fueling a helium-generating reaction or series of reactions of some kind. But we are still in deep water as to know exactly how this is occurring and why.
The results of the cold fusion experiments are still defined as controversial. Do you agree with this definition, or do you think that's a result of prejudice that has accompanied this kind of studies? Bill, why don't you talk about it first?
Well, of course they are controversial, but I don't think they deserve to be controversial. I think the quality of experiments in general, when they're performed by scientists rather than by garage researchers or by get-rich-quick engineers, I think some people might know who I could be talking about, so I've got to be careful. No, I think that the science, when it's done scientifically, has been extremely good. So
Follow up on that, because people from the outside world, people who don't deal with this community the way we do all the time, really don't have an idea of the quality of the work and research you're talking about. Could you throw out some examples of those?
well, let's suppose you were a skeptic and you thought that there was some doubt about excess heat, for example. Now, that was the common rejecting philosophy of 1989. Well, a couple of years later, they showed that, Miles showed at China Lake, that helium was produced in the expected quantities for one of the proposed reactions. And so there were two completely different measurements, the heat and the helium, and they both supported the same explanation. So even if you had doubt about one of those, the fact that the other supported it confirms that the general direction of the hypothesis was correct, that there's a nuclear reaction going on involving deuterium and producing helium.
Well, let's go back to a couple more basics, which could you explain in a few words what LENR means? And also, what do you see as the prospects of moving from pure research to research applied to industrial and domestic use of cold fusion? Let's ask Bill Collis first.
Well, I always think it's premature to put a name to cold fusion or low-energy nuclear reactions or condensed matter nuclear science when we haven't quite yet identified those reactions. So there's a tendency, we have to call it something, we think we know what it means, but it's not properly defined. I think the best example we have of very well-known low-energy nuclear reactions are, of course, the fission reactions which are induced by low-energy neutrons. And we understand that very well. And there are some models for cold fusion which follow this model in some ways, for example, the exotic neutral particle models. But they're not accepted. But it's certainly a good definition. No one can say that low-energy nuclear reactions don't exist, because you can always point out conventional nuclear fission. As for the prospects, in my opinion, in the political sense, as we can propose cold fusion as a remedy for global warming, for the depletion of fossil fuels, which are certainly going to run out one day. And it's terrible to think we're burning such fundamental resources just to create energy when there might be some much nicer, cleaner alternatives. So the prospects I see of resolving a lot of political and economic questions, maybe energy will come down to a much lower price because the fuel is extremely abundant. If we assume that the deuterium in the oceans is the fundamental fuel of cold fusion, which is quite a reasonable assumption, then the oceans would last 1 million years. And if, as others suggest, that it's actually hydrogen, protium, in the oceans, that would last well over 1 billion years. Well, the Earth won't last that long, because all life will die when continental drift and subduction of sediments stops, because there will be no carbon dioxide left in the atmosphere for plants. And we could go into a lot of details to why life won't last that long. But whatever, we will never run out of energy. We'll probably find another planet to go to or something like that. So,
All right,
thank you.